in cybersecurity, there are two things. One is working with security engineers. Context really matter in this case. It's not just detecting anomaly. It's also
Right.
making sure that anomaly is actually malicious. So they give you a lot of input on what exact pattern that you're looking for that will then help you decide on which method you can potentially use. And then the second part is definitely the explainability part. You have to think that there is a security engineer at the other side of the screen that's looking at your results.
Hello, everyone. Welcome to the Data Scientist Show. Today we have Betty Zhang. Betty is a data scientist currently working at a cloud security company. Previously, she was a data scientist at Amazon Web Services. While she's there, she has worked on a computer vision project for a major sports league. She started her career as a business intelligence specialist and later become a full-stack data scientist. She has a business degree from Queen's University. Today, we'll talk about her computer vision projects in sports, data science use cases in cybersecurity, from business major to data scientist, and what's her experience working in startups versus big tech companies. Welcome to the show, Betty.
Thanks for having me, Diana.
So you worked with a major sports league. That sounds like a very interesting project for a data scientist. How did you get involved in this project?
Yeah, so I think back then when I was working at AWS, there were just people reaching out asking if anybody was interested in working on this project. So back then I volunteered and expressed interest in working at this major sports league.
Yeah, that's awesome. Can you walk us through what was the problem you're trying to solve and what was the solution your team came up with?
Yeah, for sure. So again, this is like a huge team effort. We had so many people working on this project. It's still going on. It's been multi-year project. But basically, this major sports league, they really care about players' health and safety. So they really want to ensure that we have enough ways to analyze the data from videos and ways to prioritize players' health and safety. So the problem space is really, we had a lot of video footage of players in sports playing, in this case, football. And then we also had people that basically manually annotate collisions. So collisions is when basically two players like collide into each other. And that's when people get head injuries, right, from those collisions.
Yeah.
That's sort of where it was before, where you just had a person who's manually labeling. And they came to us asking for an automated solution using machine learning, where we can basically, instead of having a human labeler, we have a system that goes in, label all these footages and videos and tell the league, hey, these are the plays where you have the most injury or, most collision. And they can then go back to their coaches and help prioritize what to do with that information, right? So just to give you a scale, we had like 100K hours of videos. And then for one season, normally it would take like more than 100 manual labelers, because these are also specialized labelers, because it's actually really hard for a human to go in and label, hey, this is a collision or not. So it's actually a specialized person. It would take them like 6 months, more than 100 human labelers to actually label one season. So that's when they kind of came to us like, hey, can you build a sort of a machine learning solution to approach this problem?
Yeah. So if I were to approach this problem, I would say, hey, we just detect two players' helmet or their heads bump into each other. It sounds like a simple problem. Why is it difficult?
Yeah, for sure. It is actually quite complex because, again, players move so fast and it's actually really hard to just detect from get-go if there's a collision or not. So we basically had to break it down into multi-stage problem. Again, we also partner with Kaggle. So we had a competition on Kaggle. So they also gave us really good solutions. So we collaborated with multiple teams. But basically the solution ended up being like I would say like multi-stage detection, where at the first, you detect the helmet first to figure out which player you belong to, as well as figuring out which team you belong to. And then the second stage will actually be detecting the collision part, where now you know the helmets, you know who the players are, because we also had NGS tracking, which is basically a tracking data where you can map the helmets to the players, and then we can see, okay, we see a collision. So that's basically a classification model where we can have collision, or you can detect collision between different players.
Yeah, gotcha.
So that's what we broke it down.
So when you do the detection, do you treat it as a action recognition problem and split the entire video to small clips, or you're looking at frame by frame to do a object detection for a specific frame and then create some rules to see, okay, they are very close. There looks like it's a collision.
That's, again, a really good question. So I think at different stage, we basically incorporated both information. So at the helmet detection space, we basically had like frame by frame detection of the helmet and identifying, these are the helmets on this image. And then what the solution ended up doing is that it also, from there, basically you had a clustering algorithm to figure out which team the player is on. And then from there we did, because we also had the NGS data, which had the tracking. So we mapped it to the tracking data. And then we looked at, 13 frames or 14 frames. And within that, we also figured out, or we further corrected to make sure that we have the right players on the right team. So in that way, we first identify helmets per frame. And then we then loop through like 14 frames, identify helmets, and then use another sort of algorithm to make sure that we have the helmet at the right team. And then we use like a majority voting so that if you say helmet 1 is identified to player A on team A, but then if you see like on frame 13 you flip, then maybe the flipping was actually wrong. So then we correct it through like major voting and other mechanism. So that's in the helmet identification phase. In the collision phase, we basically had a CN model. And then we used a temporal shift module. Basically, we had, again, 13, 14 frames of data. We compress it, and then we feed that in. And then it also just gives you that temporal shift movement information about whether they're colliding or not. So that gives you sort of like a 3D. It's looking at 3D, but it's also able to do it at the 2D speed.
Oh, gotcha. Yeah. What kind of temporal model you were using?
So back then, we basically just used this temporal shift module. That's the one we used. Yeah.
Okay.
That basically just shifts like the actual tensors around so that, it helps. Yeah. So even before we detect the helmet, the first thing that we need to do is actually to synchronize the data. So what that means is we actually have these video footages from different perspectives. So if you think about, filming these kind of games, you normally have a end zone perspective as well as a sideline perspective. And then sometimes what happens is that these videos are not synced, which means they don't start from the same time. And then what we first had to do is to detect when the ball snaps. So in football, what a ball snap basically just means that's when there's motion happening. So when the ball drops, technically. So before the ball snap is motionless, and then after the ball snap, that's when we start actually doing the detection. That's how we lined up sideline to the end zone so that we can analyze the two videos together.
Yeah. So it sounds like there are multiple stages of this model. And in order to evaluate this whole project, you might have different metrics for different stages. Yeah. And in the end, you might also have a overall metrics to evaluate this whole project. So can you tell us how does the model evaluation works?
Yeah, for sure. So during the helmet stage, where detecting helmet, we basically just used IOU, which is basically you're just evaluating or looking at the interaction over union. So you're trying to figure out between your ground truth data, which has the helmet labeled pixel by pixel, and then comparing that to your detection to make sure that you have helmet labeled around similar size. And then because it's a video, what we also did is we did intersection over a few frames, not just that one frame, because everything moves really fast. So we had approximation there. So that's during the helmet detection phase. During the collision phase, it's just a typical classification problem. So we just looked at F1 score, precision, recall, see if we can correctly detect there's a collision going on when there's no collision going on. And then in the model, we basically just look at, cross entropy loss. Yeah.
And for this part, are you worried most about false positive or false negative? Do you have to do any calibration for the output probability?
Yeah. So we did a lot of diagnosis trying to figure out there's definitely a class imbalance problem here because you don't really see that many collisions, which is great. But then because of that, we really don't have that many ground truth data. So we did or the solution did a lot of upsampling to make sure that we have some sort of balanced data set. And that's why we primarily look at, again, precision and recall and a balanced F1 score to make sure we're capturing that. But I would say typically in this type of use case, you're probably more worried about not catching things.
Right.
So, and then that's basically also the overall metric that we used, which is precision, recall, F1 score, because at the end of the day, that's really what we cared about for this whole solution.
Yeah.
Is, you know, figure out, has this happened to a particular player during what frame, whether there has been a collision going on or not.
Yeah. So you care more about recall.
Yeah.
So, but then I assume because I worked on something similar, so we have a baseline for precision. For example, we want a precision to be at least 70%. And above that, I want to improve the recall.
Yeah. You are correct. Yeah. So I think there are not just limited to this project. I think with any sort of projects where there could be a human in the loop, because this is, again, a very complex problem to solve, then one way of thinking about it is, you know, how do you get your recall high enough, but then with a decent amount of precision, you can still have one or two specialized, you know, human labelers to go in to further refine the model, right? Because if you're catching everything, then it's just up to them to decide on whether what you caught is correct or not. But you don't want to feed them, you know, so many, you know, false positives, because it's a lot of work on their part. Still, right?
So what this model provides is not the final decision. So basically, you are providing a few collision candidates to the human labeler. So, but with this model, you still largely reduce their workloads to analyze every frame, every potential collision. So instead of say, I'm just throwing out a number there, instead of for the human labeler to look at 100 label data points, they only have, say, 5.
Yeah, I think for this project, we got it to a point where it is an automated process, because it was still better than human labelers, I think, by at least when we looked at precision recall by 10%. So it is still better. But if you, again, want to refine the model even more, that is definitely a process that can be put in place where we basically retune the model and then focus higher on recall and then send it to human labelers and have them to label a little bit more.
And I think another challenge in computer vision project, especially when it comes to video, is it just takes a lot of time to process the data. The requirement for compute is large. I'm curious, in terms of ops and putting things in production, how do you scale the solution? How do you speed up the process?
Yeah, that's a great question. Again, we have a group of really talented engineers, machine engineers and other engineers that really worked with us on this. So we deployed everything on AWS, and we used a combination of AWS batch, which is basically, just think of it as a bunch of compute that you have a Docker image, and then you can basically use that Docker image on, you know, a EC2 instance, and we coupled it with step function. So step function is just any serverless architecture sort of orchestration workflow. So it's similar to Airflow and other solutions. And that's how, and then we basically just parallelized the whole thing. And that's how we were able to scale the solution up, where, as I mentioned before, you would take, you know, more than 100 annotators 6 months to annotate one season. I think we're able to scale the solution for it to only take a week for the computer vision model to finish processing a whole season.
Yeah, thanks for sharing that. And now looking back at this project, maybe you can give us a rough estimation. What is the distribution of your time for different stages of the project? Say, what is percentage of the time for you to talk to the business, understand the use case? What is the percentage of time for you to process the video frame data, and how much time you spend on modeling, and then later communicate with stakeholder again and put things in production?
Yeah, again, I think for this particular project, because it's such a large project, we just did it in phases. But if you were to break it down like that, I would say probably like 20, 30% of time talking to stakeholders and communicating where we're at, asking for further clarifications on the requirement itself, and then probably I would say after that, just divide it evenly between the helmet part and then the collision detection as well as the scalability part. But again, we had, a huge team of people working on this. So I think as a machine learning engineer, you spend most of your time working on the engineering scalability part of it. And then, as a data scientist, your time is more spread in between all different tasks by hand. Yeah.
Yeah. So for example, if someone else want to build a project like this, so what would you say the top 3 skill set or tools they need to know in order to do something like this?
Yeah, for sure. I think top 3 skill set. One is definitely figure out where you're going to get your data, how you're going to get your data labeled, especially in, I would say, in sports industry. A lot of things are quite niche in a lot of ways and requires a lot of skills. So definitely think about how do you get that process figured out. And then second, having sufficient computer vision skills or data science skills, depending on the type of work that you want to do. And the third one would just be general language, programming skills, whether that is Python, Java, or anything that you find to be useful for this type of program. But I would say just start by figuring out one piece out and then you can figure out the rest.
Yeah. Was it stressful for you to work on this?
I think at the beginning it was a little stressful, but again, because we have a lot of people with a lot of good experiences, so I think I learned a lot from the team as well. So a lot of support.
Did you watch football before you work on this?
No, not that much.
Yeah. And did you feel you need to learn a little bit about football? How did you get those domain knowledge so you feel confident talking to your stakeholders?
Yeah, I think, I read some Wikipedia pages, watched some football. But I think at the bottom of it, it's just a computer science or computer vision project to be solved. So I think as long as you get the core, the domain knowledge part, it's not too bad to pick up, I would say.
So this sounds like a very exciting project and you learned a lot from it, working on different type of computer vision challenges. And I know you started as a business intelligence analyst, which is similar to where I started. And also, by the way, me and Betty met while we were both working on AWS project. We were actually on the same floor while the pandemic started. That's how we met. So how did you transition from a business analyst to a full stack data scientist and later acquired MLOps skills?
In school, I studied business, and then I also took a lot of math and computer science courses. And then after I graduated, I did business intelligence, which is sort of like business analysis as well as data analysis. And then I think at the time that was 10 years ago, that's when we start seeing a lot of machine learning and AI stuff. And that's when I became really interested. So I started reaching out to a lot of people in the industry that are working on really exciting machine learning problems as well as AI problems, just to ask them to meet up through LinkedIn. And I think through that process, I met a lot of interesting people. And then one of the guys basically referred me to a startup that I worked at as a data analyst. And then the startup I worked at primarily focused on demand forecasting as well as personalization. So while at the startup, I expressed my interest to be transitioned into a data scientist. So, I had great mentors at the company. So they basically give me a list of courses that I need to take and also just assignments that will help me transition over into a data scientist while working as a data analyst. So I think I did the transition and maybe it took me like a year just to complete all the courses as well as complete a lot of the site assignments for the data science team. And that's basically how I transitioned over.
Oh, that's awesome. Yeah, I agree. The best way to transition is within your company.
Yeah.
And when you send a lot of LinkedIn messages to strangers asking for their time, what was the specific thing you say? How did you craft the message?
Yeah, I think for me, it came from a place of curiosity. I was genuinely curious about the people that I reached out to. A lot of them fortunately had a lot of great blogs about it, about the work they do, as well as the company. So I think it was pretty easy for me to craft a message. I would just say, like, I read your blog, enjoyed your talk on probability, or I really enjoyed your talk on this model or that model. And I think, once people hear that.
So I actually did some homework.
Yeah.
So they know you're not just randomly sending 100 messages. It's personalized, and then you're genuine.
Yeah. I think the goal for me at the time, one part is getting into the industry, but a big part is really learn about the skill sets that are required for the job, as well as really curious about what people were doing in the space of time 10 years ago.
Yeah, that's awesome. You did that. And while you're transitioning within your company, did your manager initially agree when you asked? What was the conversation like?
Yeah, so I think the company, they were very supportive of my transitioning. It was just about like making sure that I can still do all the work I did as a data analyst. But, the company, again, like I think people work at a startup for career opportunities and for opportunity to grow with the company. So they were quite supportive, I would say.
Yeah. I think the benefit of working in a startup, sometimes you can wear different hats, and there
for sure.
are fewer rules about what exactly is your job requirement. We can definitely talk more about this working startup versus a big company, because I think there's also a lot of opportunities in big companies when you transition to different roles, different teams.
Yeah, for sure.
So later you get into Amazon. What was that process like? How did you prepare for the interview? How did you apply for the job?
Yeah, so for Amazon, the recruiter actually reached out to me while I was working at the startup at the time. So it was a very exciting opportunity. How I prepare for interviews, I read a bunch of books because I know for Amazon, it's a lot of it also comes down to culture. So at Amazon, you have the leadership principles. So I think I read like 1 or 2 books on leadership principles and just brushed on my technical skills, reading through a bunch of different books. Yeah, I think that's primarily how I also like, lead coding, stuff like that.
Yeah. And then for the technical side, how did you prepare?
Yeah, on the technical side, I think it broken into, I would say, probably 3 different categories. So there's the SQL. That's a big part of being a data scientist, is making sure you know how to extract data. So that's any data extraction tool. So SQL, PySpark. So just practice that. And then another part is just more on the data science algorithm part. So understanding, logistic regression, random forest, different algorithms in depth. Preferably if you can code it up, that's better. And then the third part is primarily programming skills. So practicing leak code or just practicing general language, trying to solve a problem using Python or any other thing. So I'll break it down into those 3 different categories.
Yeah. When I was interviewing for the BI engineer role, when I first joined Amazon, the interviewer only asked SQL and just kind of lightly mentioned, oh, do you know R? Because that was the programming language I was using. I think now it's definitely more common for people to ask lead code questions in job interviews, but I think it's usually easy, medium level questions. Do you remember, did they ask you lead code questions?
I actually don't think they asked me lead code questions. I think back then we had a take-home exam. So we were given a assignment to solve a machine learning problem. You have I think at the time you have a data set, and then they would try to ask you just like solve this problem, right?
Yeah.
And then state your assumptions, state what kind of questions you ask, and then they will evaluate your take-home assignment. And then after that, you have a few rounds of them asking you about technical problems. How did you solve the problem? Stuff like that.
Right. So the team I was at in AWS is similar to the team Betty worked on. So we are a customer-facing team. I don't think a lot of Amazon data science teams ask you to do take-home assignment. I think that's kind of specific for our teams, because the manager first want to see whether you have the technical skills to tackle a real-world problem. And secondly, they want to see whether you have the communication skills to interpret the results. And sometimes they might also ask you some challenging problem. They want to see whether you can handle those questions, because once you get hired, that's the reality of how you work with external stakeholders. Do you have any advice for people working on take-home challenges?
I would say figure out how you want to tell the story, as well as I think a lot of time pay a lot of attention to details, because I think when you have these kind of take-home assignments, you have to think about, okay, what the interviewers are trying to test you on. So one thing is definitely is your understanding of the different algorithms you can use, but another thing is your attention to detail, whether you can figure out there's discrepancies in the data itself. And the third is, how do you tell that story and sell that model to your stakeholders and explain to them why this is important to build this model, why it's better than the existing, whatever solution they currently have. So those are the three main.
Yeah, I think that's good advice, because you don't want to just throw all your data set to an XGBoost model. You want to understand the data, the solution, because there will never be a perfect model. You want to talk about the pros and cons. And I think you also brought up something very important. What is the baseline? Why your solution is better than the current solution, and to kind of quote unquote sell the solution. Yeah.
Sure. Yeah.
And later you left Amazon and joined your current company working on cloud security. Could you share what was the thought process like?
Yeah, cybersecurity, cloud security now is it's becoming such a big industry. I think every day you just have a lot of very complicated intrusions happening, especially with this whole migrating to cloud movement. There are just a lot of endpoints that now people have to think about how to protect. But it's also pretty new technology. It also takes time for people to learn how to protect it. And that's why we're here to help them address that.
Yeah. And how did your experience working at the world's probably largest cloud provider helped you with your current job?
Yeah, for sure. It definitely worked at AWS. We've definitely seen a lot of different architectures. I've used a lot of services. So coming into the environment or the world now where we're trying to protect those environments is definitely helpful, knowing or thinking that you were once a user of these services, and you can think about the ways that you might be a little bit neglectful in some ways or the other. So it's easy to put yourself in those shoes.
Yeah. And can you tell us what are the typical use cases in cloud security or cybersecurity?
Yeah, for sure. I think in cybersecurity, in data science, I will map it into 3 different phases. So there's the before phase, during phase, and then after. So before is really when you're trying to prevent any incidents from happening or prevent any attacks from happening. So that's your, vulnerability detections or detecting if there's any loopholes in your code itself. And then from a data science perspective, again, it's looking at data, think about risk management, or thinking about the probability of some vulnerability that's happening in your system. So that's on the before side. During is when you're trying to detect attack. So within that realm, what you will find is you will use anomaly detection to see if there's anything anomalous that's going on in your environment, or you might look at or use profiling to see if there's anything different. You can also sometimes use supervised learning when you have data set where that's telling you like this is something benign or there's actually a malware that's happening. So that's sort of the during phase, which is a combination of anomaly detection plus some supervised learning if you have some data on malicious attempt that happened before. And then the after phase is really after there's been a compromise, then this is the part where security engineer needs to jump in and then figure out what they do next, right? So this is sort of building evidence. This is, building the support. So from a data science side, it's more figure out how do you personalize the evidence building phase to make sure that it's easy for the security engineer to go in and figure out what happened and for them to really dive into the root cause of a breach or of a compromise.
Gotcha. In cybersecurity, it sounds like you're dealing with a lot of anomaly detection, outlier detection. What are some common techniques you use? For example, previously I interviewed someone working on a similar space at LinkedIn, and he used a lot of isolation forest. What are some models or techniques you use?
Yeah, for sure. I think, in the space, isolation forwards is definitely one way of doing anomaly detection. There's also a lot of probabilistic approach that you can use. Even we have clustering methods that you can use for anomaly detection. Sometimes you can even use deep learning for anomaly detection if you're just trying to detect any changes in text, or if you see if there's any jump in actions that are different. So it all just depends on the data, but those are definitely some more popular
Right.
methods.
So a combination of supervised and unsupervised learning.
Yep. Yeah.
So how do you decide which techniques works best for a situation? Or say, do you try all the common techniques and then just look at the output and then the metrics?
Yeah, I think it's like solving any sort of data science problem.
Yeah.
In cybersecurity, there's definitely the part of trying to work with there are two things. One is working with security engineers. Context really matter in this case. It's not just detecting anomaly. It's also
Right.
making sure that anomaly is actually malicious. So they give you a lot of input on what exact pattern that you're looking for that will then help you decide on which method you can potentially use. And then the second part is definitely the explainability part. Because again, depending on whether your solution is going to be customer facing or not, you have to think that there is a security engineer at the other side of the screen that's looking at your results. And if you can provide reasons as in why you think there's an intrusion with details, so in data science, that could be using SHAP or any sort of model explainability model to tell them, hey, these are the things that are important, and that's why we had this model results. That's better. So those are the two things that I think people normally consider in the cybersecurity space when they are building these machine learning models.
Yeah. I think it's in cybersecurity, you cannot just say, hey, this account acts a little weird, we just turn it off. Maybe it's a false positive and you have to take care of your customer. So I can see why the model interpretability is so important. So besides using, Shapley value, what are some other techniques you use, or just in general, people in this space would use?
Yeah, I think SHAP is definitely a very popular one. There's also Lime that I think people typically use. Another thing is really just working with the customers and trying to, or, work with your in-house security engineer and really trying to figure out what type of evidence are more relevant to one's space. So you can also maybe use like a probabilistic approach. And even now with, Gen AI, it's also possible given, like if you can use that, then just have that learn about your environment and you can maybe just ask it questions, like this incident happened, tell me more about it, or tell me more about the root cause that could potentially be causing stuff like that.
Oh, okay. So you can use large language models to help you with the root cause. Oh, that's pretty smart. Like I assume you might not take their answer 100%, but it inspires you to come up with some potential scenarios to interpret the data.
Yeah, that will help the security engineer to quickly figure out what could potentially happen in that environment.
Right. And let's talk more about large language models and Gen AI, because people worry a lot about their own data privacy when using, say, OpenAI APIs. So how do you approach this? Do you use OpenAI APIs, or do you fine-tune your own large language models using open source models, or do you mostly do prompt engineering?
Yeah, so I think, again, this really depends on the company, but you have a good point, right? Right now, it's still very exploratory. So I imagine a lot of big companies, for example, I think Microsoft recently released some Gen AI product for cybersecurity. But we also do have some large language models that's offline that you can probably train.
Oh, offline.
Yeah, that you can train as well. I think that's probably what people are typically using in the cybersecurity space. Yeah.
So has large language models or, say, code interpreter changed your current work process?
Not yet, but I imagine it's probably going to come soon.
Yeah. So from Amazon to your current job, has your tech stack changed? I would assume in AWS, you use a lot of, AWS tools, SageMakers. In terms of ML ops or data science problem solving, what were some tools you used before and what do you use now?
Yeah, so I think general principle wise, it's still quite similar. Like at Amazon, I was mostly programming in Python. Now I'm still programming in Python, but I guess the big difference is before everything we used was AWS specific, right? So SageMaker, we used a lot of step functions as well as DynamoDB table. Whereas now it's pretty cloud agnostic. So we primarily just work with the fundamental technology. So we use Docker image, Docker Hub, all sort of orchestration tools. So, Airflow, Kubernetes, whatever that we think works the best for the use case. You can basically use that, at a startup that you're on. You're less constrained in that way, I would say.
Yeah. So which way do you prefer?
Yeah, I think it's definitely, when you're assessing what tool to use, there's so many angles that you're looking at it, right? So one angle is definitely, is it simple enough? Does it solve the problem that you're trying to address at hand? Another aspect is also thinking about, does your developers know how to use this particular tool? So I think those are probably, I guess, like 3 different angles. So how is the tool simple enough to use?
Yeah.
Second one is, does it address the use case at hand? And the third one is, do your developers have some knowledge of using the tool? Or if not, is it easy to pick up, right? So that's how,
Yeah, I think it's a good point. It's not just about solving your own problem. You also need to think about how easy it is to collaborate with your kind of downstream or upstream workflow.
For sure.
Yeah. So what are you excited about data science and machine learning in the cybersecurity space? Because it feels like you're kind of like Sherlock Holmes, try to find those evidence, find the bad guys. What is the most interesting thing for you and what you excited about in the future?
Yeah, for sure. I think at the front of it, you're helping people, right? You're trying to protect customers' environments. We're trying to protect people's environment from being hacked. So I think on that front, it's a very nice mission to have.
Yeah.
And then also with the advanced technology, the hackers are just becoming so sophisticated in a lot of different ways. So I think on the protection front, there's a requirement to also just upscale really quickly and learn a lot of different technology. And then I think for me, I really enjoy learning about different techniques and learning about different technologies or learning about new things because I'm a very curious person. So I think that's what, one part is really the mission. I think it's a good thing to help people. And the second is, there's just so many new things. It's very exciting.
Yeah. So basically, the skill development from the hackers helps you to continue to level up and learn new skills so you can defend them. I'm curious. So when you're working cybersecurity, cloud security, is it always defensive when they invented some new ways to attack and then you try to address it? Has there ever been any use cases where you take on an offensive approach? You anticipated, they might do this, so I created some solution to block this specific attack.
Yeah, so that's, on the before side, right? Yeah. That's in the vulnerability front where you assess in your environment, what are your vulnerabilities, where you think about where are the potential weak point your system has that the intruder might use to get into your system, right? So that's how you stay on top of things. And that's ideally what our security companies are trying to get to, is to build out this sort of framework around it.
Right. And for data scientists, do you have any advice on how to protect our data, our model, our environment?
Yeah, I think one thing is definitely making sure that everything is behind a VPC, make sure all your data is encrypted, making sure that your model is encrypted and stuff like that.
Yeah. So now you have worked on startups that it was... So you have worked on, So you have worked in startup that was in their very early stage, and now your startup is later stage and you have worked in big tech companies like Amazon. So how do you compare your experiences across those different companies?
Yeah, for sure. For small startups as the data scientist, the key thing is just to iterate very fast. So you want to build a prototype really fast and be very scrappy because depends on what stage you are in. You're just trying to make sure there is a product market fit. So it's very engineering focused. It's very about, shipping things fast and iterating and making sure that you're headed towards the right direction. So I would say from that front, it's a much faster workflow. I think generally at big tech company, it's more focused on perfecting your solutions, thinking about scalability a lot more and thinking about edge cases sometimes, and just generally have a sort of a different mindset when you come to different problems you're approaching.
Right. Yeah. In startups, it's a lot of from 0 to 1.
Yeah.
In big companies, usually they already have some existing solutions. You're thinking about from 1 to 10, or like you mentioned, I don't know, patching some loopholes. Yeah. What about career development? You transition your career in a small startup, they're pretty flexible and supportive. And in big companies, they're also very clear role guidelines and leveling guidelines. So what do you think about the career development? Which environment is better for a data scientist?
It just depends on what each person is looking for. For people who are looking to grow their career very quickly, I would say startup is probably a better place to be because it's easier to be very visible, have really high impact, because if you're working at a startup of 30 people, you just end up doing everything, right? You're wearing many hats. You're a data scientist, you're a software engineer, where you're working on many different things. So it's easy to learn a lot of different things and easy to scale up and be in different domain. But if you really want to focus on solving one specific problem or really dive deep into one specific area, it's probably better if you have a big company that can support that specific effort. So then you can go in and just really just do research in the area, because you have, let's say, software engineers that can help you build that solution now or scaling, or you have product managers that help you define the roadmap better. So you can really focus on that research. So I think it just depends on each data scientist and how they think of their career.
Okay. Yeah. Let's talk about challenges. What are some challenges working in startups and big companies?
The challenges of working at a startup is definitely the problems are a lot less defined. So a big part of it is you having to go out there and trying to figure out, do we need to build this? Where are we going with this? What is the angle? And then again, quickly build a prototype to make sure that the solution makes sense. And this is something that you want to continue spend time and effort in. So it's a lot of prioritization and making sure that there's sort of a product market fit for whatever solution you're building.
Yeah.
So I think that would be the challenge. The speed is really the challenge, because you really want to get out there fast and beat your competition.
Yeah.
I think at the big company, some of the challenges we'll get is probably trying to understand how to work with different teams, or try to figure out how to have a lot of time more visibility into the work that you do, and try to really perfecting maybe the niche skills that you're trying to develop, and understand how at an organizational level how everything kind of fits and work together, which could take a little bit of time because you just have so many people and it's quite complex.
Yeah. How do you kind of navigate working with different teams, different organizations? It's not like in a startup, you can just say, hey, let's work together. You might need to go through their manager to get their approval because, hey, they have plans on their own sprints.
Yeah, for sure.
What's the difference between working in an early stage startup versus a later stage, well-founded startup?
I think the big difference, again, with the really early stage, is really about finding the right product fit, market fit. At a later stage startups, then you start thinking about, you had to juggle both, right? You have to think about how do you scale the solution because already you have some product market fit. So it's a matter is you have to think about is your product scalable across more customers? How do you get to more customers? And then how do you scale? So I think those are, two different type of questions.
Yeah. And now when you think about your career, what are some mistakes you have made?
Early on in my career, some mistakes I've made is probably not knowing how to prioritize. For example, when I was younger, if I were to be given a task, I wouldn't really ask too much about it. I would just do it.
Yeah.
I think now it's more thinking about how do you kind of carve your own paths, do things that you think are, for me, things that I think are interesting, that I think are impactful, then I'll try to actively seek out that project or try to participate in that project because I think it gives that impact. So I think back then I was probably just more passive. Now I'm more active in trying to define my career.
Right. How do you carve out your own career path?
For me, it's very curiosity led and also thinking about the impact that you have. And as far as for me, I'm thinking about what are things I'm good at and what are some things I'm not very good at. So for different project, you can think about, okay, this project, I really want to showcase my skill set. So you participate. And then for other project, could be, I really want to learn more about these things. And that's how you can participate. It's just more about what you're trying to focus on and what interests you that you think will have, a broader impact on the company or from your own personal perspective.
Right. Because your manager, your team always going to have some opinion on, you need to work on this because we need someone to work on it. But you have to be the person to think about, do I want to work on this? What are some other things I want to work on? I felt very inspiring in the beginning. I asked you, how did you get into the computer vision project for the sports league? And you just volunteered. So kudos to that. And what was important feedback you got from your managers or colleagues that have shaped your career?
Yeah, it's interesting. Basically, I think again, when I was younger, I would give a suggestion, but I wouldn't face it as a suggestion. I would face it as a question. I would say things like, "Oh, but do you think this is better?" And that confused a lot of people because they didn't realize that I was trying to give them a suggestion.
Yeah.
So that was a good feedback. A manager that had a time was like, "Oh, Betty, don't phrase your suggestion that way. Phrase your suggestion as an actual suggestion."
Right. And then you need to be more assertive.
Yeah, more assertive in how you phrase that. Just don't be like, "What do you think?"
Yeah, right. And did you have a mentor?
Yeah, I've had a lot of mentors help me through, at the transition phase, but also at AWS, so they're really helpful in helping you carve out a career path.
Yeah. What was the most important thing you learned from them?
The most important thing I've learned is really, it's more about not just looking at yourself, but also thinking about the people around you, like your coworkers, as well as other teams. Like, how do you build out a solution or build out a project that's really fun for everybody and not just focus on like, I did a good job. It's very collaborative and you think about ways for them to really help your project grow and become better and how do you help everybody?
Yeah, that's a good point. You were also a mentor collaborating with this company called the Sharpest Minds. So basically how it works is you help aspiring data scientists get into data science, get a job, and then they do revenue share for their first year of salary. Can you tell us from your experience being a mentor, what are some common mistakes your mentees make?
So what I see, it's a lot of people try to learn everything and try to do everything. They're trying to learn, like Airflow on top of Kubernetes, on top of AWS. They don't really have a focus. So when I come in, I normally tell them, okay, think about what you're interested in, what domain you're interested in, and then just focus on one thing at a time, right? So just focus on data analysis. Don't worry about programming. Just think about what are some interesting insights you can draw from this data and let's just start there instead of trying to learn everything.
Yeah. And now a lot of people with stats or data science background are trying to learn more full stack skills. Do you have some advice for them besides just cracking lead code questions?
Yeah, I would say work closely with your software engineers.
Yeah.
And then see if there are small tasks that you can actually pick up that you think, again, more leaning on the machine learning engineering side, right? So if you see there's a lack in some in some monitoring effort, then maybe you can be the one picking up the monitoring effort, monitoring the machine learning system rather than the software engineer, or helping with data drift. So I think there are a lot of engineering work that as a data scientist you can pick up that will help you build your software skills as well as ML ops skills.
And if data scientists want to learn more about cybersecurity, do you have any books, blogs you recommend?
There's a good podcast on, I think Google Cloud. They have a good podcast just on cybersecurity that people can listen to.
Yeah. And how do you see your career grow in the future?
In the future, it's definitely about building things that I think are impactful, that can help people in a lot of ways. And I really want to also make sure that I can help different teams grow and be able to contribute in the ways that, again, like a situation. I really want to be the person that kind of supports that sort of project development or product development.
Yeah. Do you see yourself as a principal ML engineer, data scientist, or a VP, a CTO of a company?
That actually, I don't know. I don't think I have a very specific goal in mind, but in my mind, I think it's more, where do I think I can contribute the most? And hopefully that'll lead me to a path that makes the most sense.
And what are the short-term career goals for you?
We're trying to build products, so a lot of it's definitely trying to understand how the product is helping our customers.
What are you excited about in the next few months?
I think the industry is moving so fast, and it's so great to see. So I'm really excited to see in the next few months what kind of new tools we're gonna get that's gonna help improve our productivity or help us build better, not just at work, like in personal life, right? Like I want to have another like AI assistant even to help me better allocate my time, or having some sort of AI tool that help me increase my productivity outside of work as well.
And how do you manage your own like work-life balance?
It's less of a balance. It's more priority. There's always a priority at different time in your week even. So on that day, there's a lot of work that needs to be done, then you just prioritize work. And then on another day, if there's other obligations with family or with friends, then you might have to kind of prioritize that a little bit more. So I think it's quite fluctuates. I think at the end of the day, it's just trying to be able to optimize your time and get the most done.
Yeah. And what do you think about the future of machine learning?
There are just so many different angles to this. One way I'm thinking about is I think there'll be a lot of engineers that, use a lot of AI solutions, but try to build a really good product that hopefully make everybody's life better. So that's one angle. Another angle is I think a lot of data scientists are going to be a lot more productive with their time, because hopefully with machine learning, they're able to draw insights a lot quicker and can iterate really fast and can provide a lot of business value to both internal clients as well as external clients, right? So you can see how that could potentially save a lot of time for data scientists. Now they can actually do a higher level work, trying to directly create impact more easily.
Yeah. And for folks who want to get in touch with you, where can they find you?
You can find me at LinkedIn.
Before we wrap up, there's anything else you want to tell our listeners?
I think that's pretty much it. I mean, Diana is like a great friend of mine, and I'm just so proud of her for having this podcast and really sharing a lot of experiences with people and, showcasing a lot of work that a lot of data scientists have done. So thanks to you.
Yeah, thank you so much, Betty. I learned a lot from our conversation, and I think it's great that we finally do this recording in person in New York. Yeah, thanks for listening, and reach out to Betty if you want to learn more about her career. Thanks.
Thank you.